exponentials and logs. So I'm going to start with this one real quick. You're not solving anything on this question. You are literally just writing this in a log form. So this is exponential form because you see an exponent. You're just going to drag the base of the exponent goes over to the other side. When you do that, that drags the 4 down on the level with the rest of the equation. And you just introduce the word log. The base of the exponent becomes the base of the little subscript for the log. And then you just kind of scooch the 625 to the side. That's all you have to do. Now, the next one has kind of like 2 little concepts I want to review. What is the base of a log if you don't have a base?
1. 0.
0. 10. 10. All right, so if you don't have a base, and I like to write that in for this kind of a question because I'm going to swing it over to the other side. So this says write this in exponential form. So that means I don't want to see the word log. To do that, the base of the log is going to swing to the other side. And you just leave the 1 over 100 right where it's at. And the 10 is going to push that -2 up in the air into being an exponent. So be 10 to the -2 power. And you're not doing anything else here. These are true statements. You're just rewriting it in a different form. All right, now I'm going to use the same equation for 2 and 3 in terms of the general exponential. And you might want a calculator to actually answer the question here, but this is in the form y equals ab to the x. Okay, I'm just going to write this on this question so you guys can have it.
Oh, this is helpful.
A is your initial amount. All right, and then x and y are going to be variables we're going to plug numbers in for or just evaluate to find. But the b value, this is the tricky part. So based on the question, it's either 1 plus your rate or 1 minus your rate. And that just depends on the question. If it's 1 plus the rate, that means you're working with growth. So the amount is getting bigger. If it's 1 minus the rate, it's decay. Exactly right. So we just got to read the question to figure out which one we want to use. The other tricky thing here, the rate is usually given to you as a percentage, so you're going to have to convert that to a decimal. So that's what's going to go on this question. So a new car sells for $38K, depreciates 9.8%. So I'm just going to scooch the decimal place over 2 spots to write that as a rate, so it'd be 0.098. And then it says write a function that models the value of the car. Use your function to determine the value of the car after 4 years. So the 4 years is going to be x, which is going to be the time. So all you have to do here is write y equals what the value of the car would be. We're going to do 38,000, that's what you paid for initially. So if it depreciates in value, goes down. So it's 1 minus that 0.098. So I'm just going to do 1 minus 0.098. It's 0.902. I know, I had to do it on my calculator, I wasn't sure. So anyway, I just did that on my calculator. Now, all you have to do to answer the question, it says, what's the value of the car after 4 years? So x is just going to be 4 is all that means. So we're just going to type this right in, 38,000.902 to the 4th power. Now, we're talking about the value of a car, so this is money, so I would round to the nearest hundredth. So I'm going to say it's going to be worth about $25,154.16.
Down to the cent.
Down to the cent. All right. Now, this is almost the same question, but this one's going to not be decay. So it's growth, I guess. All right, so this says a house is purchased at $225,000. So that's the initial amount. This is usually true when you have real estate. So it appreciates, that means it increases in value. So B for this question is 1 plus the rate. So just don't forget you have to change that percentage to a decimal. It's just going to, bless you, scooch the decimal over 2 spots. So it's 1 plus, sorry, I just wrote that totally wrong.
Fail.
I know, fired. Okay, 0.063, my fault. I mixed the 0 and the 6 up. So this would be 1.063. If that value in the parentheses, that's your B value. If that's bigger than 1, that's going to indicate to you that you have growth. And a general model would just have x as the exponent. This says how much is the house worth after 10 years. So you're just going to replace x with 10 to actually answer the question. So 225,000 is what you paid for it. 1.063.
Is the rate, and then you have to put the 10 in. Yeah.
Perfect, perfect. All right, so this is pretty good for only 10 years.
That was really good, actually.
$414,491.06. All right.
Can I learn?
Now, there's a question on the final like this, and I just thought the wording was kind of weird. Now, if you have here, this is basically telling you to find your B value. And what's going on here, if it has a plus, it's to indicate growth. If it has a minus, it's to indicate decay. So if this is plus, I would just do 1 plus. You just have to convert the percent to a decimal. So I'd do the 0.45, so 1.45. Negative 30 would be 1 minus 0.3 or 0.30, so this would be 0.7. Now this one was the one I thought was weird. This is growth, so it's going to be 1 plus. How would you write 320% as a decimal?
I think it's, isn't it?
3.2. What you do, so your decimal here would be after the 0, you scooch this over 2 spots, that's true. The other thing you could do, if you weren't sure, you'd take your percent and divide it by 100, and that will give you the decimal as well. But that one I thought was a little bit weird. So the B value there would actually be 4.2, which is fine. The B, anything bigger than 1 means it's going to be an increase. This is just a lot of increase. And then I just have a plain negative 0.7, or negative 7. So this would be 1 minus 0.07. So this would be 0.93. You're just going to convert the percentage to a decimal. If you're ever not sure, just take the decimal, or take the percentage, divide by 100. So you could do that with any of these. So 30 divided by 100, this would be 45 divided by 100. That'll give you the decimal. And if it's plus, you're going to add it to 1. If it's minus, you're going to subtract it from 1.
No, this is actually really good.
Good. All right. You're going to write a general exponential given 2 points. Here is the thing I want you to remember. Use whichever point has the bigger x value first. That'll just make the whole problem so much easier to do. So I have 2 points here. I have 111 and I have 344. So obviously the one with the bigger x value is the 3. What you're going to do, you're going to use this general exponential equation. In for x, you're going to put x, and in for y, you're going to put y, just the coordinates from the point. And a and b will be variables. So I'm going to do 44 equals ab to the third. So just put y in place of y, x in place of x. And you just repeat that real quick with the other point.
Oh, okay, so then you just add the other one.
So in for y, you put 11, in for x, you put 1. Now, this is actually a system of equations. You got 2 equations with 2 unknown variables. And it's been a minute since we've done this. You actually take and divide the top line by the bottom line. That's why it's going to be easier to start with the bigger x value, because it's going to avoid you hopefully having a negative exponent, which would happen if I had flipped this. The reason that we do this, every time you just have a and a, so when I divide that, they cancel each other out. All right, this is 4. Okay, now I'm using exponent properties here. If I do b to the third divided by b to the first, do you remember what that becomes? Or what do I do with the exponents?
Subtract them.
Okay, so it would be
B to the second, actually.
perfect.
All
right.
right.
Good,
I'm on today.
good.
Y'all, I'm on today.
Now, here's this one thing I'm going to say to you guys. If you take an even root, which you're going to do here, you're going to take a square root, your b value cannot be negative, so I'm not going to put a plus and minus in front of this. The b value has to be greater than 0, so we're just going to use positive 2. Don't put a plus and minus if you end up taking a square root or a fourth root. And I know this is a little bit extra, but you do have to plug this back into one of these equations to figure out a. So I'm just going to use the second one because it has a little bit smaller exponent. So 11 a times b to the first. I figured out b from doing that system right there. So this would actually just be 11, 2 to the first is just 2. So 11 is equal to 2a. And this is not the greatest number ever, but a is going to be 5.5. The actual answer to the question, you have to plug both of those numbers in to this general form that they're going to give you in the problem. So this is y equals Don't multiply these together, just keep them separate. 5.5 times 2 to the x. The reason you don't want to multiply them together is because you have to do the exponent first in your order of operations. I guarantee on the multiple choice, there'll be, like for this question, there would be one that said 11 to the x. So don't multiply those together. Should have two separate values for a and b.
Okay.
All right, now for these guys, on the actual test when we took this, you guys had to do these by hand with no calculator. We're not going to take your calculator away from you on the final at all. So let me just show you a quick way to do this. So if you have scientific or graphing, doesn't matter. I'm just going to do the change of base. So this is the same. Log base 2 of 8 is the same as the log of 8 divided by the log of 2. Now you cannot like reduce that. So you can't just change that to be, let's say, the log of 4. It's two separate things. You have to do log of 8 divided by log of 2. But you can just do this on your calculator, scientific or graphing, either one. So I'm just going to type literally like log 8. It should automatically pop up a parenthesis, so just don't forget to close it. Yeah.
You said you're not going to take a calculator for this question on the test.
You can use your calculators on the whole test, is what I'm saying to you. I'm not going to grade your work on this. All right, so we're going to do log 2 divided by, or log 8 divided by log 2, and this should be 3.
There's something on screen actually.
Sorry. That always pops up in this
I don't know, it's
class.
so strange. I'm trying to learn, not even that.
Oh gosh, all right. Don't forget, if you don't have a subscript, the subscript is 10. All right, so this is the log of 10,000 divided by the log of 10. It's just the log of whatever you're taking the log of, divide by the log of the subscript. If you want to do it by hand, I'll show you real quick. When we did these by hand, I had you guys just change them to exponential. This would be 10,000 equals 10 to the x, and then you just have to figure out what the exponent would be, which in that case it's 4. But you can do it that way on your calculator as well. For the c, you can't take the log of a negative number. So for this question, like, you'd get an error message. So there's no simplify. Dude, I'm going to kick you out. It's just getting annoying now. All right, so no taking the log of a negative number. If you try to do that on your calculator, it'll give you an error message. This last one, it's the log of 1 over 81. I would just use like a little division key if I was typing this into the calculator. So 1 over 81 divided by log 3. Just make sure you close the parentheses after that first one. You really don't have to do it after the second, but you should type the log button 2 separate times, and this ends up being -4. Is anybody having a question? I'm just going to try and do a couple more here before lunch. All right, now, these guys are log properties, and if you are multiplying, I'm going to do this in 2 steps. If you're multiplying two things, so I have 2 times x to the 6, that's what I'm taking the log of. If I break that apart or expand that, that property is that I can add these together. So this would be the log base 6 of 2 plus the log base 6 of x to the 6th power. And I know probably some of you are thinking there's another property I could use here, which is true. If you have an exponent, that can actually come down in front of the log, and you can multiply that by whatever you're taking the log of. It's called the power rule. So I'm using the product rule here because I had a product I break apart with addition. And then your power rule, just drag that exponent down in front, be 6 times the log base 6 of x. Doesn't change the base or anything, we're just expanding it. And then the other one, I have a division problem. But before I start this, let me ask you a question. If I have the square root of x, the square root is the same thing as what power? Do you guys remember? Not the second. Like a fraction. Square root is the same thing, 1/2. 1/2. I know that it's kind of tricky because the index is not written in there, but the index would be 2, and you just have x to the first. So the square root's the same thing as the 1/2 power. I'm going to write that on this one because I can use the power rule. All right, now, I do have 2 things divided. So this would be the log x to the 1/2 minus the log of y to the 3rd. And then I'm going to do, if you want to do this all in one step, you can. I'm just trying to isolate the two properties so you can see both. And I'm going to drag that exponent down in front. So this would be 1/2 times the log of x minus 3 times the log of y, totally expanded. So that's the quotient rule with subtraction. Division turns into subtraction. The previous question, multiplication, turns into addition. Okay, and I'm going to try and do this one problem before lunch. This is really important because I had you guys just like solve these when we did them in class and round to the nearest thousandth and things like that. This is going to write an exact answer, so they're just not going to type what I'm going to do in the calculator. So, does anybody remember the base of a natural log? Like a regular log is 10. Do you remember for a natural log? It's a letter. E. Okay, to get rid of the natural log, you're just going to swing e to the other side. And just remember, that's not a variable, it's a number. You have 2x minus 9. That's going to push that 6 up to being an exponent. We get rid of a log by using an exponential. This is now exponential. Now, after that, what would you do next? We're not going to lunch until 26. You'd add 9, right? You remove the 9, and then I would have to divide by 2. Now, what's going on here is the way they're going to write this. This is e to the 6 plus 9, the whole thing divide by 2. That's how the answer is going to be in the multiple choice options. All right, we'll finish the rest of this when we get back from lunch. All right, guys. The question number 10 here, don't multiply the 5 and the 8 together. And I just wrote to the side, it says show your steps, but the actual question on the final is going to be kind of like the one we just did right before lunch, where they're going to ask you to leave an exact answer. So don't multiply the 5 and the 8, you're going to divide by 5. Get 8 to the 3x, I'm just dividing 45 by 5, that's 9, it's a nice number. Okay, now, the only way to drag my exponent down on the level with the rest of the question, because that's where my variable's at, we're just going to convert this from an exponential to a log. So to do that, the 3x is just going to come down on the level with the rest of the question. Now, the base of the exponent, which is the 8, becomes the little subscript or the base of the log, and you just kind of move the 9 just to the side a little bit. And then to answer the question, then we would just divide by 3. And they're just going to leave the answer right like that in the multiple choice options on the test. So it'll be like log base 8 of 9 divided by 3. That's how they would write the answer instead of actually typing that into the calculator. Now, do what? Oh, okay. Now, the next 3 here, these are all formulas that I'm going to have you guys, or at least encourage you to write on the little cheat sheet you're going to make yourself. But the first one is compound interest with a specific amount of time. So like monthly, weekly, something like that would be what you're looking for. The amount in the account, that's A, is the principal, that's P. So the initial investment or the initial amount you borrow. And then it's 1 plus whole fraction, your rate, which is R, divided by N. N is the number of times you compound the interest during the course of 1 year. And then it's got an exponent that is NT. So number of times compounded multiplied T for time. Okay, now in this you got to figure out what you're going to plug in. So you invest $3,500 in a CD, that's going to be your principal. Compound interest monthly. So if I have monthly, there's 12 months in a year, so your interest would get compounded 12 times for the year. Now all these, they give you the rate as a percentage, so just don't forget to change that to a decimal. So 6.5% would be 0.065. And then how much is in the CD after 6 years? The 6 years is the time. So we'll just type this entire thing into the calculator once you set up the equation. So the amount you're going to have, this is money, so I'll just round to 2 decimal places when we get going on this. We're going to do 3,500, 1 plus. Now, my interest rate here is 6.5%, so we got to put it in as a decimal, so 0.065. And then if we compound the interest monthly, the end is going to be 12. Now, the only thing I would tell you to do here, if you can't see it, I'm just going to put parentheses on mine. The exponent is the number of times compounded multiplied by how long you're going to leave this in the bank. So this is 6 years. So monthly would be 12 and I'd multiply that. X is going to be 6 years, so I'm plugging in 6 for X. The only thing I would tell you to do is just type in your calculator, but just put parentheses around that exponent. Or figure out what that number is. 6 times 12 is 72 if you want to put it in like that. Otherwise, you could just type the entire thing in just like I wrote it. You can't use the fraction key for that fraction if you're using a scientific calculator because it does have a decimal in it. So just use the division key. And then for my exponent, 12 times 6, either put that in parentheses or you could just type 72. If you're not getting this answer, I will be happy to look at your calculator. And this is money, so I'm going to round to 2 decimal places. That would actually round up to a whole number for this example. It's $5,164 even would be what that would round to. The next one is very similar, but the formula is different. If it says compounded continuously, and that's going to involve the E. So this is the PERT formula. Amount in the account is your principal. E, not a variable, it's that 2.718 number. It's got its own special button on the calculator. And then the exponent here is the rate multiplied by the time. That's the general formula. For this question, it says you invest $6,000. Annual interest rate, the R here, 0.0425, because you got to change that to a decimal. Just scooch the decimal place over by 2 spots, or you can take the number and divide it by 100. How long will it take for your investment to be worth this $9,991.75? So actually what we don't know here is the time. So it's just going to be a little different because we're going to solve for a different variable than we did in the last problem. So I actually know how much is in the account. That's that $991.75. The investment was $6,000. E is not something we're going to replace. It's just that 2.718 number. My rate, 0.0425. And then my variable is actually up in that exponent with the T. Okay, now, first thing we do not multiply the 6,000 in the E. You're going to get rid of the 6,000 multiplying by that, so I'm going to divide. Now, it's not going to be a nice number when you do that, so I'm just going to leave this as 991.75 divided by 6,000 equals E to this 0.045. Oops, sorry, I just messed that up. 0.0425 T. The only way to drag that exponent down on the level with the rest of the question, we got to swing this and convert it to a log. So what you got to remember with E is E, I'm going to write this to the side just in case you guys forget. That would swing to the side and it would be log base E, but that has its own special button that is the natural log. So if you're working with E and that's going to become a base, we're just going to use the natural log. What I'm actually going to type into the calculator, I'm going to do natural log, and I would take that $9,991.75, brings that down on the level with the rest of the equation, so we'd have 0.045 or 0.0425 times the time. All you're going to do, just type natural log. You don't have to do change of base or anything. It has its own special button. So I'm typing natural log on my calculator. Should just say LN on the button. Probably around the log button if you're not sure where it's at. And don't use the fraction key. Just use a division sign for this, because if you use a fraction key, it won't like it on a scientific calculator because you guys have a decimal in that. And then the only other thing, I'm just going to leave it right on my calculator screen. I'm going to divide this by that 0.0425. But I'm just going to leave it right on the screen. And time here is going to be 12, and that would be years. Is anybody having a question? Okay, now the last one here, number 13. This is another formula from this unit. There were a bunch of formulas in the exponentials and logs. This is for half-life, so it's just a little bit different than a general exponential, because if you're working with half-life, you know the decay factor is going to be 0.5, so you know the B value. The A value is your initial amount. The other thing that's just a slight difference is the exponent is X over the half-life. Now, this entire thing you should just be able to type in your calculator, but I just want to give you the formula. So it says the half-life acetaminophen, that's Tylenol, is 2.5 hours. If you take 325 milligrams for a headache, how much will be left in your system in 8 hours? So in that case, the 2.5, that's the half-life. The 8 hours is going to get substituted in for X, and the 325, that's the initial amount. So I'm just plugging these guys in. Y will tell you how much would be left in your system after whatever amount of time you're going to plug in for X. We're going to plug in 8 hours. So the general form would be X over the half-life. To actually do this problem, I want to know how much is left in my system after 8 hours. So the 8 goes on the top, and the half-life goes on the bottom. The only thing I would tell you here, kind of just like the last question, I would put parentheses around that exponent, or I would figure out what that is. So I'm doing 325 times 0.5, and then, again, you can't use your fraction key here because you got a decimal. Just do 8 divided by 2.5. Just put parentheses around that. Otherwise, it'll take it to the 8th power and then divide the entire answer by 2.5. So you don't want to do that. This should be about 35 point, I'll just go 2 decimal places because I don't think it tells you, milligrams would be left in your system after 8 hours. So those formulas are all going to be important because you're going to use them on the final. Now, all I'm doing at the bottom, this is just a graph of y equals log base 2 of x. I don't know why you're not writing this down. This is all in the final. All right, all you're doing here is describing, just describing how these changes to the equation would move the graph. All right, so just log base 2 of x. If I change that and I put in parentheses with the x, if I put x minus 5, and then we have a plus 7 on the outside, think like left, right, up, down, how would that move the graph if this was my new equation? Like, what would the x minus 5 do? Right, 5. Perfect. What would the plus 7 do? Up 7. Okay, I know it's really tricky. So whatever's inside with the x is the opposite way you think, left or right. And whatever is outside the operation, so outside the log, this, you're just going to copy that number, and that's going to move the graph up or down. So with the, this is true for any function. X in with the x in the operation, like a square root. If we had a quadratic, if it's in with the x, it's the opposite of what it looks like because it's what sets it equal to 0. And then outside the operation, like to the side there, it's just going to go up or down. So if I look at these, if I have x plus 5, this actually goes left 5 minus 7 is down 7. If I look at this equation, I just have x minus 4. So this would just write 4, and then it doesn't move it up or down because I don't have anything added or subtracted, like if you wanted to think about it like that. We're not moving up or down, so nothing on the side there. Now this, nothing inside with the x, so it doesn't move it left or right. Outside is just going to be to copy that, so that would be up 6 is all that's going to do. Now I'm going to do a couple on the back. This will be really quick, but I put some more graphs on the back here. So no, these will be multiple choice, but like basic, okay, so there's a question on the test that's like, you know, it's got the options and it'll say which one of these graphs is exponential decay, and you have to pick out the multiple choice option. Okay, so here's, this just says label, growth, decay, or neither. Now, automatically, if you have neither, it's got to point down. One of these two. If you have decay, or if you have neither, it doesn't go up. All right, so this first one, it's exponential, but basically what happens here is the a value is negative. That's what causes the graph to flip over. So that's not going to be used for exponential growth or decay, but it's still exponential, but if it points down, it's decay, or it's neither one. Now, growth and decay, if you start, they have to point up. All right, both of these point up. If it starts big and gets small really quick, this is decay. If it starts small and gets big really quick, this is growth. So if it points up, it's one of those two. If it goes down from left to right, it's decay. If it goes up from left to right, it's growth. If it points down, it's automatically neither one. And it could look like it. This one is this first picture, but it could flip over and look like that too, but that's a neither. All right, now you don't have to graph anything here. This is just y equals 4 to the x, and it's saying like manipulate the equation to reflect these transformations. So this says 3 units left, 2 units up. Okay, left or right is going to be with x and the opposite of what you think. So to me, left is like a negative, but it's actually going to be a plus. Whatever is up or down, you're going to put that outside whatever the operation is, and you're going to copy that number down. So here's how this works. I'm going to shift y equals 4 to the x. So you'd still have y equals 4, and then x is going to shift in the exponent left or right. This says left 3, so it would just be plus 3, the opposite of what you think. And then 2 units up would just be outside that operation, totally to the side, so 2 units up would just be plus 2. If I just go 5 units down, so it'd be 4 to the x, we're not shifting left or right, so the exponent would just be x, and we're going to go 5 units down, so that would be minus 5. Now, this one says 2 units to the right, so to me that thinks positive 2, it actually looks like a negative 2 in the exponent there, 2 units to the right, x minus 2 in the exponent. Horizontal asymptote. A horizontal asymptote would just underline the graph. If you guys look at what I have here, the asymptote would be, this would be y equals 0 on the example. So if that's going to go up to y equals 7, it's just going to shift the graph up 7 units. It would just take that x-axis and move it up 7 spots. So I would write plus 7. And then these 2, and then we're done. All right, now I just want to write before we do this. Can't take the log of 0 or a negative. So when we solve these equations, if we plug them back into the original problem, if it causes any of these sets of little parentheses here, if it causes it to be 0 or a negative number, it is possible to have an extraneous solution on these questions. Both of these problems actually have an answer that does not work. They're 2 different problems though, because I've got one with a minus and one with a plus. So these are 2 different properties. If you have a minus, we're just going to scrunch these together. Single log minus turns into division. So I'm just going to take the x squared minus 1, put that on the top, 2x plus 2, put that on the bottom. Just kind of condensing it using log properties, subtraction turns into division. To get rid of the log, you just change this to an exponential, just swing this to the other side. You're going to keep the x squared minus 1, 2x plus 2. This side would become 3 squared. Base of the log is going to push that 2 up in the air into being an exponent. And I know this looks kind of complicated, but it's not bad. If I square 3, that's just equal to 9, right? I would just turn this into a little proportion. That's all I would do. And then we can just cross multiply. If I do that, I got to do a little distributive property with the 9. But if I do 1 times x squared minus 1, that's just going to stay x squared minus 1. The other side would be 18x plus 18. I know this is kind of tricky, but this is going to be a quadratic, and that's how it is on the test too. So I'm going to subtract 18x and subtract 18. I want to try to keep my squared term positive if I can. When I move those to the other side, the 18x, when I subtract that, just there's nothing to combine that with. But when I subtract 18, I had a negative 1 over here, so that would actually make that negative 19. And I promise if you get a question like this, you'll be able to factor it. Can you guys think of 2 numbers would multiply to get you negative 19, add to get you negative 18? Exactly. Yeah, you're 19, 1. The 19 has to be negative to get that negative 18. The 1 has to be positive. Now, my 2 answers then, 19 and negative 1. So you just got to check really quick because one of these is not going to work. So you cannot take the log of a negative number or 0. If I plug in 19 to either one of those, we're golden. But if you plug in negative 1 actually makes both of those sets of parentheses equal to 0. You cannot take the log of a negative number or 0, so that -1 is actually an extra answer. So just the 19 works. The other question we're going to do here real quick is very similar, but this is addition instead of subtraction. So if we scrunch these guys together, you got log base 2, you got x minus 5 times x plus 1 is really the only difference. Instead of dividing, we're just going to multiply the two together when I write it as a single log. We're going to get rid of the log the same way. We're going to change this to an exponential. The 2 base of the log pushes that 4 up in the air to be the base of an exponent. So this is going to be 2 to the 4th, which is just 16. It's just a number. You can use your calculator to figure it out if you don't know it off the top of your head. That's fine. I'm going to do a little FOIL here. We get x squared plus x minus 5x minus 5. So x squared minus 4x minus 5, that's equal to 16. This is a quadratic again. You want to set it equal to 0. So I'm just going to subtract 16 from both sides. And then try and think, can you think of two numbers and you multiply them? They would give you -21. But the same two numbers would add to get you -4. All right, so multiply to get -21, add to get -4. I got 1 and 21, 3 and 7. Those are my options. So it's got to be the 3 and 7, right? If I have to be -4, it has to be -7 and +3 for the factors. -7 times 3 is -21. -7 plus 3 is the -4. Actual answers to the question, +7, -3. And you just got to make sure, let me see if I can pull this back down. You can't take the log of 0 or a negative number. If you plug in 7, you're good to go on both of those. If you plug in -3, though, that makes me take the log of -8 here. It also makes me take the log of -2 here. So that one would be an extra answer. Just the 7 would work.